So I fetched one of these fin pipette repeating pipettors. These are from Thermoelectron or Thermoscientific. Thermo Fisher is now one company. And they have various different tip sizes from 0.5 to 50 milliliters. I have a 12.5 milliliter tip here. You see it says 12,5, made in Germany, where commas are periods, right? And at my 12.5 milliliter tip, you can see that at wheel position 1, each pressing of this little lever will result in 250 microliter volume. Wheel position 2 is 500, wheel position 3 is 750, wheel position 4 is 1,000 microliters or 1 milliliter, and then 1.25 milliliters or 1,250 microliters. So I want a wheel position of 4, so I can dispense 1 milliliter at a time. So I'm going to adjust that so that the wheel position is in position 4, and I'm going to attach my tip. You see there's a little kind of slot there that grabs onto this. That sticks in there like that. So now when I depress this lever here, that raises the plunger, and then when I press it, each time I depress it, it dispenses 1 milliliter. So I want to put 3 milliliters into each of these vials, which means 3 presses of the plunger. And it also tells me that at wheel position 4 I get 11 strokes, so I can get 11 dispensings of 1 milliliter. 12.5 milliliter total volume, but only 11 actual strokes. So these you can set down because the syringe or the pipettor body is not connected to anything that will have liquid in, right? This is just basically a syringe. So I need a beaker. And I'd like it to be cleanish to pour the ethyl acetate into, because the syringe tip obviously won't fit in the jar. So we need a total of 18 milliliters, which will be a couple of different fills. So we can put the tip in there and just push this all the way down to fully load that syringe. And then I always like to dispense one just to make sure that there's no air bubbles in the tip. So now we're adding 3 milliliters to each of these. And I run it down the side. Don't want to contaminate the tip, obviously. So there's the linalool. And just to make sure I didn't contaminate the tip, I'm going to wipe that off, because it did splash a little bit. And this is the 2-phenyl ethanol. 1 milliliter, 2 milliliters, 3 milliliters. These vials are what we call 1 dram vials, and 1 dram is about 4 milliliters. So they were the appropriate size for making up 3 milliliter samples. The 2-phenethyl acetate. It's 9 strokes so far, plus the extra one. So at this point I'm going to go ahead and refill. Before I move on to filling the remaining 3 vials. This is the guaiacol. And the eugenol. And finally, the vanillin. And to eliminate the rest of it, I'm just going to pull that all the way up. And now I can take my tip off. And actually it's just ethyl acetate, so I can take this apart and let it dry out. And I'm pretty confident I didn't contaminate anything, so I'm going to return the unused ethyl acetate to the ethyl acetate bottle. Put that beaker back. Right, just volatile solvent, it'll evaporate. So now I want to make sure these are mixed thoroughly. And to do that, I'm going to use a vortex mixer. This is set on touch, so when I insert it, it will shake that around nicely. So I have approximately 20 milligram per milliliter samples of these, which should be an appropriate concentration for getting a good thin layer chromatography result. And I think you can see that they're all nice clear colorless solutions, which means that my hunch that they were all freely soluble in ethyl acetate turns out to be true. Ethyl acetate is a good solvent for a wide variety of biological flavor and aroma compounds. So we have our standards ready for thin layer chromatography, and we have our TLC plates and our spotters, and we're all set to start the TLC lab.